Hi, as I say, my name is Brian Munsell. I'm with the Bureau of Labor Statistics. I'm going to talk a little bit about an R package that I've been developing, which I call SA Utility. And essentially, what it is I'm going to talk a little bit about the package basics. I'll give you some examples, and I'll wrap up in the 7+ minutes that I have. So basically, I've been developing a number of utilities and doing the work that I do at BLS. Helping with seasonal adjustment, and I put a collection of all of these into a package. It uses output and routines from Christoph Sax's seasonal package. I use version 1.9.0, as Richard says. It has some advanced features, particularly with composite adjustments and operating with multiple time series. And these are more or less routines that are useful for research, review, and publication. So first of all, let's read in some data. The data that I'm going to use is the 4 main components of U.S. unemployment. Unemployed males 16 to 19, unemployed women 16 to 19, unemployed males 20 plus, and unemployed women 20 plus. So I'm going to load those all into a list structure within X13, within R. And so I'm using the import time series function here to read everything into this, this data list. So now I'll go through and show some examples. One first example is going to be how to select X11 seasonal filters. And we'll talk a little bit about generating model diagnostics, summaries from regARIMA models, and I'll reflect on what Eric said and talk about how I generate outlier regressors within the within R. And so first, to select X11 seasonal filters, my routine uses a couple of different procedures for selecting X11 seasonal filters that ask about whether these X11, what X11 seasonal adjustment would be closest to a seats adjustment. Depito and Planas in 2002 essentially looked at the total adjustment filter. And so they used the seasonal moving average coefficient within an airline model to see which seasonal filter would get closest to a seats adjustment. Chu, Chow, and Bell, they were looking at the canonical decomposition and seeing which combination of seasonal and trend filters would get closest to an MSE, would get closest to a seats adjustment, seats canonical adjustment. So I programmed both of these into my function. And so here's a demonstration. I'm taking the entire data list and essentially using lapply to continually run this optional seasonal filter routine. This use MSR argument is essentially, if you can't estimate an airline model, it's going to use the MSR, the moving seasonality ratio from X11. So this uses the procedure from Depito and Planas' paper. And this, notice this has an argument that says DP limits equal false. So I'm going to use the procedure from Chu, Chow, and Bell. I then take both results and I basically create a matrix of the different results. It's just going to basically give out a text of which seasonal filter. And so you notice here, this is I put them into a matrix, and here's so for each series, you see the choice for Depito and Planas and for Chu, Chow, and Bell. Chu, Chow, and Bell seems to prefer larger filters than Depito and Planas, but I tend to go with the Chu, Chow, and Bell filters. But this is a way you can use the seasonal, select X11 seasonal filters that will get you adjustments that are close to seats adjustments. Next, talk about how to generate model diagnostics. Usually, we sometimes use the UDG function within seasonal to grab diagnostics from the UDG file generated from an X13 run. So this routine will create a matrix with modeling diagnostics from either one series or a group of series. Now, I find this useful if usually at the beginning of the year, I'm looking at like 160, 200 series. So it's useful in doing triage for a large number of series to say, okay, when I'm looking at models, which models seem to be fitting the series best, which models do I need to do a little bit of work on. And I'll mention that there are similar routines for, say, X11 seasonal adjustment diagnostics. Here, I'm just going to show a similar thing for modeling diagnostics. So here, I'm taking the data list, and we're just going to run seasonal. It's going to do like an automatic model and an automatic transformation analysis. It's going to do an outlier adjustment. So here it's just going to do what I would consider a default run on each of the series in that list. And so next, in version 1.9.0, you have this issue where it adds basically there's a C's object for each individual data point, which is, basically each individual data series that's in the list. It has a similar element, only with the C's object. But in version 1.9.0, it added a call argument. So I can't run my function unless I filter in all of the C's objects. So this creates a data list that has C's objects only. And then using my all model diagnostic list function, I put the list of the C's objects. And then I'm basically saying I want AICCs included. I want output automatic outliers included. I want normality statistics included. And I also want the results from the spectrum. And so here, I'm going to go back for one. UN underscore diag is a matrix of all the diagnostics. If you go over here you see there's a column for each of these different diagnostics, ARIMA model, number of regressors, et cetera, et cetera. Well, some of the things I like to look at most are like the ACF test. Sometimes I look at the normality statistics to see whether we've got some problems with the normality. And here I'm just producing this matrix. Here, this first column is essentially the model that's identified. You see that there's some issues with the autocorrelation test, the Jung-Box autocorrelation test. So if I were looking at this, I'd be going through and maybe changing some of the models here to get better results for the ACF test. But you can see here you have all of the different diagnostics are included as different columns within this data matrix. So next, you have a bunch of models. Now sometimes you want to share with somebody else what the models actually were, the coefficients or the t-statistics, and you can see sort of so here, I'm going to create a summary of the ARIMA models within a list of seasonal objects. And so I'm going to output that as a matrix, and that matrix can then be easily saved into an Excel file, which I can share with others. And so here again, I take my auto C's only, all the automatic models, and I'm going to use lapply to run the get regARIMA estimates matrix function over and over. This add diff argument essentially says basically true. If it's true, I'm going to add the differencing operators, show the differencing operators. And here you see this is the regARIMA model for the unemployment for 16 to 19-year-old males, and here's the regARIMA model for the 20+ males. And this is sort of set out here it's a much nicer format than what you get, say, from the raw numbers produced by the seasonal package. I also produce t-statistics for each of the t-statistics for each of the coefficients. So here you see we've got temporary. This has a temporary change regressor in April. Here we have a temporary change regressor in March. You get to see a little bit what just the magnitude of some of these estimates are. Finally, I've got a bunch of routines to generate outlier regressors. I have 3 routines, one for each type of outlier regressor. It returns basically a TS object that essentially has the regressor. You might ask, why do you do this when X13 generates them for you? Well, you might want to use the same outlier in other modeling routines. You might want to have, like, say, if you're trying to do a Kalman filter extraction of the same thing, you might want to generate these same regressors and use them in a common filtering routine. Now, it's also, as Eric talked about in his talk, X13 will only allow you to use one decay rate at a time. If you specify a decay rate for the temporary changes, you have to use that for every temporary change you specify. So this allows me to generate whatever temporary change I want with whatever decay rate I want. And so here, I'm going to add temporary change regressors as user-defined regressors in an X13 run within seasonal. So here, I'm just basically saying what's the starting date and the ending date of my regressor. Here is and so here I've got this this function. Here's the date for the temporary change, where the temporary change should start, starting the regression, ending date of the regressor, and TC alpha essentially says what the value of the decay rate is. So I'm gonna generate 3 of these: one for an alpha 0.9, one for an alpha 0.7, and one for an alpha 0.5. And so here I'm going to run seasonal. I'm going to run Cs, and this is an interesting way of running this within the very latest version of seasonal. I'm creating what's called basically a multiple time series. This is like a time series matrix. So, but each column is essentially going to be the same series. And so here, from here on, these are all of the, essentially the arguments that I'm going to run on each column of the matrix. But down here, I have a list, and each of the list is it's going to basically have, like, to specify what regression I want to run, what user-defined regressor I want to run for each column of this matrix. And so what seasonal does with this matrix, this time series matrix, is essentially runs X13 on each column of the matrix. And this list argument allows me to control what regressor, what user-defined regressor is run on each of these columns.
50.
So now, so this is essentially the object, this is these objects in a list. I'm going to give them a name. I'm going to give each of them a name, essentially. And so now, just change the name of each of these so that I know what the names are. And then I'm going to use the UDG function within seasonal to just grab the AICC from each of these objects within this list object. And so here you see a list of, you just basically see each of the AICCs for, and you notice here, this AICC for 0.5 is much lower than each of these. So if I were going to run this later, I would use the TC of 0.5 rather than the default one of 0.7 that's run in the program. So wrapping up, I have other routines of interest in this package. I like to sometimes, when I've done a bunch of default runs, I'll basically port all the C's objects into external files and then make the changes I need to make in that external file and read it back into X13. So I have functions to read these C's objects as basically to external files so I can run them later. And I have something that saves C's objects to X13 spec. So if someone just wants to run X13 on the series, we're using the options I've developed, I can give them a whole bunch of X13 spec files based on the runs I've done. Within R. Augustin Marvel developed a program called Terror, which basically goes through your data and sees whether there are outliers or large outliers that might be due to human error. And I created an R version of Terror. I have a function that generates the outlier critical value as outlier critical value as defined in Leung. Again, yes, X13 does this for you, but I've used this in my weekly seasonal adjustment work when I'm doing automatic outlier identification for weekly series. And there's a lot of different routines to extract the specific diagnostics, model components, etc. I've got a whole bunch of things to just extract specific things like the QS, like the ACF stuff, just a bunch of different diagnostics and stuff, and lots of other different utilities. I have the current version saved in GitHub. I believe it's bcmoncel/packages will give you like the compressed tar file for that. So you can get that from there. And I thank you for your time.
Thanks, Brian. As always, that's some cool stuff. Okay, we went over, but you know, we certainly have time for questions if people want to hang out here a little bit longer. There was some good stuff in the chat.
Mm-hmm. I'm going to say I see Bill's point, and I think Bill is right. I don't think they considered the 3x15, the Depitone Planus, so they wouldn't have chosen a 3x15. But I don't think they would have chosen a 3x15 for stuff. So that's a good point by Bill.